Hello everyone. Welcome to the lecture for the course Refrigeration and Air Conditioning. Today we will continue with the same chapter, that is air conditioning process calculation, and we'll see today about the last point of this chapter, that is evaporative cooling. Myself Sumit Bardia, Assistant Professor, Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, etc. In the today's lecture we will cover the following points like introduction to evaporative cooling, classification of evaporative cooling, in that direct evaporative process, indirect evaporation process, multi-stage system or a combination, and the last point, that is advantages and disadvantages of evaporative cooling systems. Introduction to evaporative cooling or air conditioning system. Actually, summer air conditioning systems capable of maintaining exactly the required conditions in the conditioned space, which are expensive to own and operate. Sometimes partially effective systems may yield the best results in the terms of comfort and cost. Evaporative air conditioning systems are expensive and offer an attractive to the conventional summer air conditioning system, which are hot and dry. Evaporative air conditioning systems also find applications in hot industrial environments where the use of conventional air conditioning systems becomes prohibitively expensive. Now, evaporative cooling has been used for many centuries for providing thermal comfort in dry and hot regions. This system is based on the principle that when moist but unsaturated air comes in contact with the wetted surface, those temperature is higher than the dew point temperature of air, some water from the wetted surface evaporates into the air. Now the latent heat of evaporation is taken from the water, air, or both of them, in which the air loses sensible heat but gains latent heat due to transfer of water vapor. Thus the air gets cooled and humidified. The cooled and humidified air can be used for providing thermal comfort. So that is the introductory part about the evaporative cooling or air conditioning system. In the next slide we'll see about the classification. Now the principle of evaporative cooling are provided by these three processes, that is direct evaporative process, indirect evaporation process, and third one a combination or multi-stage systems. We will see one by one. Now first is direct evaporative cooling systems. In direct evaporative cooling, the process or conditioned air comes in direct contact with the wetted surface and gets cooled and humidified. So here this is the wetted surface, this is air washer. Now in this figure the conditioned space is there, which is connected to blower with the air washer, water pump, filter, and outside air is entering to the air filter, which enters into the air washer, and then it will be transferred to the conditioned space. Now the evaporative cooling system and the process is shown on the psychrometry chart. Hot and dry outside air is first filtered here in the filter and then is brought into contact with the wetted surface or a spray of water droplets in the air washer. So this is air washer. The air gets cooled and dehumidified due to simultaneous transfer of sensible and latent heats between air and water. So that is shown by the process OS in this psychrometric chart. The cooled and dehumidified air is supplied to the conditioned space, where it extracts the sensible and latent heat from the conditioned space. So that is also shown by SI in the psychrometric chart. Finally, the air is exhausted in the state I. In an ideal case, when the air washer is perfectly insulated and an infinite amount of contact area is available between air and the wetted surface, then the cooling and humidification process follows the constant wet bulb temperature line and the temperature at the exit of the air washer, which is equal to the wet bulb temperature of the entering air. That is, the process becomes an adiabatic saturation process. Now in the actual system, the temperature at the exit of air washer here will be higher than the inlet wet bulb temperature due to heat leaks from the surrounding and also due to finite contact area. Now one can define the saturation efficiency or effectiveness as we know that epsilon equal to T0 minus Ts divided by T0 minus To with respect to wet bulb temperature. Now, depending upon the design aspects of the evaporative cooling system, the effectiveness may vary from 50% to 90%. So, the amount of supply air here, amount of supply air required, that is we are calling as MS, can be calculated by energy balance equation, that is MS equal to QT divided by HI minus HS. So that will give you the amount MS, that is supply air mass to the conditioned space. Now compared to the conventional refrigeration based air conditioning systems, the amount of airflow rate required for a given amount of cooling is much larger in case of evaporative cooling systems, which is shown in figure already. So it is clear that for a given outdoor dry bulb temperature, as the moisture content of outdoor air increases, the required amount of supply air flow rate also increases rapidly. And a threshold moisture content value, the evaporative coolers cannot provide comfort as the cooling and dehumidification line lies above the conditioned space condition I. So that is the drawback. Here at point I it is lies above it. So thus the evaporative coolers are very useful essentially in dry climates, whereas the conventional refrigeration based air conditioning system can be used in any type of the climate. So that is about the overview of the direct evaporative cooling system. Now we will heading towards the indirect evaporative cooling system. What is the difference between direct and indirect, that we are going to see here. Now here figure shows about schematic of the basic indirect evaporative cooling system, and the process is shown in the psychrometric chart. Now as shown in the indirect evaporative cooling process, two streams of air, primary and secondary, are used here. Two streams, that is primary and secondary, are used. The primary air stream becomes cooled and humidified by coming into direct contact with the wetted surface here, O dash, here this is O dash, while the secondary stream, which is used as supply air to the conditioned space, decreases its temperature by exchanging only sensible heat with the cooled and humidified air stream, that is OS. Okay, so what is S here? Supply air to the conditioned space. O is secondary air. Now thus the moisture content of the supply air remains constant in indirect evaporative cooling system, while its temperature will be lower down or drops. Now obviously, everything else remaining constant, the temperature drop obtained in a direct evaporative cooling system is larger compared to the indirect cooling system. In addition, the direct evaporative cooling system is also simpler and hence relatively inexpensive. However, since the moisture content of supply air remains constant in an indirect, this may provide greater degree of comfort in regions with higher humidity ratio. Even in modern day indirect evaporative coolers, the conditioned air flows through the tubes or plates made of non-corroding plastic materials such as polystyrene or polyvinyl chloride. On the outside of the plastic tubes or plates, thin film of water is maintained. Water from the liquid film on the outside of the tubes or plates evaporates into the air blowing over it and cools the conditioned air flowing through the tubes or plates sensibly. Even though the plastic materials used in these coolers have lower thermal conductivity, the high external heat transfer coefficient due to evaporation of water more than makes up for this. Now the commercially available indirect coolers have saturation efficiency as high as 80% around. Okay, so here the process is shown on the psychrometric chart. O dash, that is primary air passing through the wetted surface. Then O dash E, that is from blower to exhaust. And then secondary, that is secondary to supply air, that is OS. So this indirect evaporative cooling system is, the process is shown on the psychrometric chart. Now next is about the multi-stage evaporative cooling. Now we have seen the direct and indirect. Now we need to go for modification, that is to improve efficiency we need to go for some modification in direct and indirect. So similarly in the multi-stage evaporative cooling, several modifications are possible with improved efficiency of the evaporative cooling system significantly. One simple improvement here is to sensibly cool the outdoor air before sending it to the evaporative cooler by exchanging heat with the exhaust air from the conditioned space. So that is a simple improvement we can do to improve the efficiency. Now this is possible since the temperature of the outdoor air will be much higher than the exhaust air. It is also possible to mix outdoor and return air in some proportion so that the temperature at the inlet to the evaporative cooler can be reduced, which will be improving the performance. Several other schemes of increasing complexity have been suggested to get the maximum possible benefit from the evaporative cooling systems. For example, one can use multi-stage evaporative cooling systems and obtain supply air temperatures lower than the wet bulb temperature of the outdoor air. Thus, multi-stage systems can be used even in locations where the humidity levels are very high. Okay, so here we can use multi-stage evaporative system for improving the performance, and these two parameters that we have discussed is very much important in order to get high efficiency of the system. So multi-stage is an option to improve the performance or efficiency by reducing the temperature of the air to the inlet of the cooler. Now next point is about the advantages and disadvantages of evaporative cooling. First we will see the advantages. Now, first one is lower equipment and installation cost. So that is the advantage of evaporative cooling. We require a lesser equipment and also the cost will be lower down. Here in the second point it is written lower operating and power cost. Energy saving can be as high as 75%. So that much saving that we can achieve through evaporative cooling. Next is ease of fabrication and installation. It is very simpler to fabricate and installation. So the lower maintenance cost will be there. Again, it ensures a very good ventilation due to the large air flow rates involved. 100% very good efficiency, especially in the 100% outdoor air applications. Now better air distribution in the conditioned space due to higher flow rates. The fan blowers create positive pressures in the conditioned space so that the infiltration of outside air is prevented. Infiltration we have discussed, that is the air is entering through the cracks of windows or opening of doors. Last one, very environment friendly as no harmful chemicals we are using in this evaporative cooling system. So these are the advantages which we can use it for our applications. Even here written that is 100% outdoor applications we can use the evaporative cooling. What are the disadvantages here? Now of course the moisture level in the conditioned space could be higher, so direct evaporative coolers are not suitable when low humidity levels in the conditioned space is required. So we can use indirect evaporative cooler without increasing humidity. Second, the airflow rates required airflow rates are much larger, so this may create a draft and high noise level in the conditioned space. Precise control of temperature and humidity is not possible. So that is again disadvantage. So again may lead to health problems due to microorganisms if the water use is not clean or wetted surface is not maintained properly. So that again leads towards the health problem if you are not using properly the air washers or wetted surface in order to increase the humidity level. Okay, so these are the advantages of evaporative cooling which we need to remember while designing any air conditioning system. So we'll complete it here the fifth chapter. In the next lecture we are going to start a last chapter, that is air distribution system. Thank you.